Alright, there's a tricky measurement, a tricky alignment calibration procedure doing a laser disc that's pretty critical. The video, that once it gets decoded off the laser disc, it eventually gets fed to an analog to digital converter, and so that it can do frame store for CLD type of playback, and also time-based correction and stuff. But the important part is that when you feed an analog to digital converter, the high level is it. I mean, you can't go above a certain level or you lose information. So the video coming into the A to D converter has to be at a very, very exact level. According to the service manual, 633 millivolts, or 1.633 volts, plus or minus 3%. That's a pretty hairy, tight measurement. And it's also kind of tricky because you're measuring a waveform. It's not just simply, like a signal that you measure. So what you're supposed to do is measure the very, this is 100 IRE. This is the brightest a disc can get. And then you have to measure it to the very bottom of the sync pulse, because everything between these two lines here is all that the analog to digital converter will see. So if this signal is too high or too low, if it's too high, you'll just lose stuff because it won't be in that between those lines. If it's too low, then you don't get enough resolution in the A to D conversion process. So this is a really critical adjustment, and it needs to be just right on the money. So it's really almost impossible to do on a regular scope because you don't have the precision to really set it. But on this waveform monitor, I'm using the Tektronix 1748 waveform monitor, it's designed to do this kind of stuff. So what's cool is that I can set these two cursors like you see here, and then I can just move them around and measure exactly where this is. So at the very top of the sync pulse over on this side, right, I just set that at like where that would be, and then I look at where that lands up here at 100 IRE, which is pretty much right in the middle of that, so that's perfect. So, but setting this adjustment, doing this alignment is tricky without the right test equipment. You can't just use a regular scope for this. This has to be done very carefully. This whole trick also works, of course, for setting a number of different alignments on the output of the player too. Video output, chroma levels, sync pulse pedestal adjustments, things like that, where you need a really good look at the video waveform, and you also need a good way to measure it voltage-wise. So this is actually pretty cool. I did this just by hooking a scope probe to the back of the monitor and leaving it unterminated, so that it's basically working just like a scope, but a far more accurate scope. Anyway, that's how to do a correct alignment of the video going into the A to D monitor, or the A to D converter.